Lesson 2 for integration. Now in the first lesson we looked at the basic rules, which are we increase the power by 1 and we divide by the new power. And we're thinking of integration as a way of undifferentiating. One of the things that we didn't consider last time that we're going to have a look at today is the fact that if I have a function which is, say, x to the power of 4, if I differentiated that, I'd multiply by the power and reduce the power by 1, so I'd get 4x cubed. If I was to integrate that, I would get back x to the power of 4. However, if I had another function, which is x to the power of 4 plus 7, and I differentiated it, I would also get 4x cubed. And so when I integrated the 4x cubed, I'd end up with x to the power of 4, and I'd have no reference to the 7. If I'm going from the differentiated function and trying to work backwards to the original function, I have no way of knowing if this constant was there or not there, or how big it was. Is it positive, is it negative? So what I need to do is just consider the fact that there might be some constant there. And so we use the letter C to say that we know there's some constant there. Okay, we're going to start to bring in some notation at this point. When we're asked to integrate something, we'll be using this symbol. And that means I'm going to integrate the following. This bit is the function that we're going to integrate. And finally we have, in this case, dx. And we've come across this when we did Leibniz notation before. That means with respect to x. So x is the variable that we're interested in this case. Now when I integrate x cubed, I'm going to increase the power by 1, and I'm going to divide by the new power. But I'm not sure if there was a constant or not in the first place, so I'm going to write plus c just to cover myself. And that plus c is called the constant of integration, because without any additional information we're not sure what the original function was. We'll learn later how we can use additional information to work out what this constant is, but at the moment we're just going to have to remember to put plus c because we're not sure what the constant is. This is called indefinite integration because we don't definitely know what this constant is. Okay, we're going to go to our notes, page 1. In the first example, we're asked to integrate x squared with respect to x. So I'm going to increase the power by 1, I'm going to divide by the new power, and I'm going to remember my constant of integration. Okay, the second example, we're asked to integrate x to the power of negative 3. Again, with respect to x. So I'm going to increase the power by 1, and remember, be careful with your negative indices. 1 more than negative 3 is negative 2. I'm going to divide by the new power, and I'm going to add my constant of integration. I'm just going to tidy this up, and I'm going to do that using my index rules. Because x is to the power of negative 2, I'm going to pop it down here to make a positive index. And the third example, I have x to the power of 5/4. So I'm going to increase the power by 1. 5/4 plus 4/4 is 9/4. Divide by the new power and add the constant of integration. Now, dividing by a fraction is the same as multiplying by that fraction upside down. So in this case, I'm multiplying by 4/9. I'm going to tidy up this here using my Indus rules. So 4 is the order of the root, 9 is the order of the power. So the 4 goes on top, along with the 4th root of x to the power of 9, and that's all divided by 9 plus c. Okay, and we'll just check our understanding for today. Okay, so what are the 3 steps that we carry out to integrate? We have an additional one this time. And can you integrate x to the power of 3/4 with respect to x? When you've completed this, you're now in a position to do exercise 9G. Again, this is one that I think you can do many of them at home, so that in class we can focus on the trickier ones. You may want to leave the ones starting from M onwards, so that we're in class, you can get some help with them.